Okay. We'll see if anybody else comes, otherwise we will finish early and go. Okay. So, one of the final things remaining in this course is about roads and paving, and then I'll try to show you some software if I can find it myself. Anyways, so roads and pavings are part of the external works. Okay, they are done. The books which I have given you, the roads are taken as the pathways. Okay, the one which we have, for example, if you go outside the building, so they are the pathway, right? So these are the roads which they are talking about. Okay, the actual roads, the highways. I asked you where did you cover it, right? The cut and fill and so on. Okay, and you did it in surveying, but did you calculate the quantities in surveying? No. Okay, so we will go through the same slides which we are supposed to cover in highway then. Did you cover in highway or not? Okay, so I will cut and fill quantities. Cut and fill quantities. Earthwork quantities, right? Anyways, so the example which you will see here, you can still use it for the quantities of the roads, the highways, okay, but they do not cover the intersections, the calculation for the intersections. Okay, so the specifications for roads and highways is less restricted, more restricted as compared to building. This is my building. I can say, okay, make the floor height 3 meters, 4 meters. Okay, so I define according to the purpose. So the height of this room could be more than your room at your home, okay, or could be less, whatever. Okay, but it can change a lot. But for roads and streets, we don't have such flexibility. Okay, you do not define your own specifications. Okay, so you have to strictly follow what the government is saying, what the authorities have already mentioned. The roads can be of two types. The highways which you see normally, they are made up of asphalt, right? You have asphalt on the top. Okay, these are called as we have two types of highways. One is made up of asphalt, the other one is made up of concrete. Okay, so the ones which we use are mainly made up of asphalt. Okay, so they have asphalt and then they have aggregates with them, and the other layers are also aggregate. Then we have the other one which is made up of concrete. When it's concrete, then you take concrete as what you have done in buildings. Okay, you'll calculate the height and the width and the length, and you will calculate as cubic meters. If it is precast, then you will take the square meter area. Okay, so these are the we have the types of roads we have. The other one which is made up of asphalt, in the book they are calling it macadam roads. Okay, so macadam means the asphalt and aggregates. Okay, macadam is the name given to the surface which is made up of asphalt and aggregate. Okay, yeah, the two. So the first one, concrete pavement or concrete roads, are called as it just came to my mind and I slipped again. So we have the macadam roads which are called as flexible pavements. Okay, and the concrete ones are called as what's the opposite of flexible? Not flexible. We have flexible and we have rigid. Rigid. Okay, so the concrete is rigid and the asphalt one is flexible. Okay, here they are calling them as concrete roads and macadam roads. So macadam made up of asphalt and aggregates, which is flexible, and concrete meaning rigid. Okay, So the rigid and flexible is because of their behavior. Concrete is rigid and asphalt is more flexible. Okay. Uh, in the roads you will have main holes, right? You may have holes which are for other lines, utilities. So if you are keeping something for lighting, for main hole, for anything, and that area is less than 1 square meter, we don't do any deduction for it. So we'll keep it as it is. So you calculate the quantity complete without any deduction. And this is the same as flooring. Okay, so if you have a hole or an opening in your floor which is less than this area, again no deduction required. So the standards are same. Okay, so the works, when we define the road works, if you have seen in NRM 2, when they define the excavation or when they define the formwork or something, they give limits, right? Less than 300 millimeters, more than 300 millimeters. So in the same way, the work for roads are divided according to their slopes. Okay, they are divided according to their slopes. So you have the level and you have the two falls, which is falling on one side, like this. The whole road has one side slope. Okay, and cross slope is this. Cross fall is this. Correct? So we have level, we have fall, and we have cross fall. Okay, and then we have the and these obviously when you are talking about fall or slope, then the slope can be less than 15 degrees or more than 15 degrees. Okay, so the road can be level, one category, two fall less than 15 degree or two fall more than 15 degree, or it can be cross fall less than 15 degree, cross fall more than 15 degree. Got it? So total 5: level, two fall, 15 up and down, cross fall, 15 up and down. Okay, so these are the different levels we have. Okay, if you are working in shallow channels, so channels are shallow means the depth is less. Okay, so if the depth is less, then you will include it. Okay, but for large channels, the lining means the thing which you put on the side to protect it from falling down. So you have a channel, right? Okay, on the side of the channel you put something so that when the load comes it does not fall. Okay, that is called as lining. Okay, or the water does not go into, the channel is for water, right? So the water does not go into the road or the sides. Okay, so the lining is for that, for protection, for taking the load and for protection against water. So that lining for shallow channels is taken as the area. For deep channels it is taken as linear, so the length. Okay, you will take the length. In all cases labor charges are included, same as what we have seen in the buildings. Okay, we did not calculate labor charge for concrete, for excavation, nothing, right? We calculate the quantities only, same thing here. Okay, then we have gravel roads. They are calling them roads. Well, obviously you will not find them on highways. Gravel means type of soil, yeah, type of soil. Okay, so in some cases, especially you may have seen in villas and near parks, outside the park, in the parking area, they just spread the soil or the aggregates just for beauty. Okay, and it's open area, you can park there and you can walk on there and you can ride the bicycle and everything. Okay, so those are called as gravel roads. Very loose definition of gravel road is the road which does not have a solid surface. Okay, a gravel road is a road which does not have a solid surface. Okay, so there is material, loose material. You compact it, you put it, level it, compact it, and that's it. Huh? Yeah, you can be arrangement of clouds. Okay, so they are very similar to macadam roads, because macadam roads, asphalt you see on the top, right? It's just the surface, but under the surface is just like a gravel road. If you remove the asphalt, is very thin layer. If you have seen a road construction or road excavation, asphalt is this much only. After asphalt is just aggregates and soil and so on. Okay. So gravel can be taken same as macadam road, because macadam road is most of the time just gravel. Okay. And what else? In some cases we use bricks and blocks as well for paving. You already see them on the sidewalks, right? Sidewalks are all made up of bricks and blocks. Okay. So they can be measured in the similar manner. But the only thing is that measurements are taken on the exposed face. Okay, the top. Okay, so if you are taking the area, number of blocks, is only for the exposed surface. Okay, and then we have the things which you provide on the side of the road. Okay, for example, curbs, blocks. Okay, things which you see on the side. This is called as a curb. Okay, so you have the curb. Sometimes you have, I already talked about the channels, water channels. Okay, and you may have lining, edgings. Okay, so these are, this is for water. This is for protection of the vehicle, so it does not go off the road. And this is edging is to support the road, support the material of the road. Okay, so these items can be measured linear, lengthwise, because they are along the length. Okay. Okay, this is an example of a road. Okay, and now if you look at the drawing, you will understand this is part of a villa or something. You see, it's a T road. 10 meter this side, 30 meter this side. Okay, so it's not a full highway. It's not a street, which you will find. It's not a local road or something. They are much longer. They are much longer. Okay. First of all, try to understand the drawing so that other things are easier. We have 30-meter road here, and that 30-meter road has curves at the end. You see the curves on the top and bottom. Got it? And then we have a 10-meter road in this way. Okay. Beside the 10-meter road, there is a path. Okay. So it's like you are coming from the gate, you go inside, you come on this road, you will maybe park here, and then you will come out of your car and you start walking on this path. Okay, so this last 1 meter is for walking. Got it? Okay, so that's why you see a curve here. So this is the road, and this is the path. They are different. Okay, and this is, you can see, it's raised. Okay, so in no case the vehicle can go like, obviously they can go, like they will feel, oh, I am doing something wrong. Okay, got it? Okay, so this 30 meter the road, this 10 meter the road. Beside the 10 meter you have 1 meter of path. Clear? For both the roads the width is 3.6 meters. Okay, and you see the two curves for the longer road. Okay, the 30-meter road and the 10-meter road, their material, their excavation, their curves, everything is same, which is like this. So you have 150 millimeter of hard core, 150 millimeter of concrete slab. Okay, this is a curb, and this is the foundation of the curb. Got it? And this is the width of the foundation, and thickness 150, looks like 150. Okay, clear? So this will be on the other side as well, right? Both sides, and it will be for both roads, for this one and this one. Okay, now if you look at this diagram, tell me which one is this. Is this for 10 meter or for 30 meter? This section. Is this for 10 meter or 30 meter? 30 meter. Why? 10 meter. Why? You can see the path. The 30 meter road doesn't have the path. Okay, clear? But they did not give us any other section. This is the only section we have, and this will apply to 30 meter as well, but only up to here, or only up to here, sorry, only up to here. Got it? Then you have the taking of list. Okay, so you have the excavation, you have the disposal of the soil from the excavation, You have compaction of the ground, you have earthwork support, you have the trench, you have the filling under the pavings, okay, membrane, concrete bed, surface treatment, tamping, not measurable, I did not include it, okay, reinforcement, okay, design joints, wherever the slab is joining with the curb, we need the joint somewhere, okay, concrete road curb, path curb, so they are different. This is the curve of the road, this is the curve of the path, they are different. Okay, what else? Adjustment for bell mount area, okay, macadam paving, okay, so this is just the top, okay, and I believe it's done here on the path, okay, an adjustment for soil disposal. Adjustment for what? Soil disposal. What am I adjusting? So I excavate the soil. I have excavated the soil. Now I will throw it somewhere, right? In that throwing of the soil, I have to make some adjustment. Adjustment for what? We already did it in for buildings and substructure as well. What was the adjustment? What was the adjustment? When you excavate, now you are calculating soil to throw off. Okay, so I excavated 100 cubic meter. Will I throw all the 100 cubic meter? No? No? What adjustment? Yeah, some of it will be backfilled, right? So adjustment for that. Backfilling. So they were calling it backfilling. Here they are calling it adjustment for disposing of the soil. So whatever you are adjusting is going where? Backfill. Okay, I excavated 100 cubic meter. I am backfilling 20 cubic meter. So 20 cubic meter will be subtracted from the soil which I am disposing of, right? So same thing, backfilling and this thing is same. Clear? Okay. Okay. Now, last time I was making a fool of myself, so this time I thought on every page I will put the drawing with the arrows and everything. Okay. So at least you know I did something. Okay. Length of the road. Okay. So they are calling the road as the road and this 1 meter strip as the path. Okay. So the road is the complete road, horizontal one and vertical one. And the path is just the side one. Okay. Clear? Okay. So the total road I have 30 meter this side, 10 meter this side. Total length of the road 40 meters. Make sense? Okay. Now the width of the road. Okay. You look at the top drawing, the plan, the width of the road. The width which you see is how much? 3.6 meter or 3600 millimeters. Right? In that we will add the curb and the curb is on both sides, right? So 127 here, 127 on the other side. Clear? And then in that you will add the spread. I am doing it for excavation, bulk excavation. Bulk excavation. So I have this plus spread. What is spread? Again, something which we did in substructure as well for excavation. Came in the exam as well, right? What was the no. I'm doing it for excavation. I will calculate excavation now. So I'm adding the road width, makes sense. I'm adding the curve, makes sense. Then I'm adding something else. What is something else? Can you show me in the drawing? Projection. Huh? You were saying something else? No, you were saying the same thing, right? Spread. So they are calling it spread. Okay. By the way, there are two books. One is called as Willie's and the other one is called as Pocket Book. Okay, I've already uploaded both of them. Okay, they are using the same sheets as what we have been using in the lectures. Okay, and they have examples as well. I don't know because I took, to be honest, I took the lectures from the last instructor, okay, and he gave me this. Okay, so I have been following it till I came to this point where the everything he said is finished, but the contents are not finished. So I looked into the books. There's a book of Datta, the Indian author, which is very messy. You saw one figure from that book in the exam, and you liked it, right? Yes. Okay. But to your benefit, that question was only by 20% or something. Right? It was tough and less marks, which is good for you. You had the more marks with the easy questions. Anyways, the Datta book has more explanation, more examples, but they are not following the same sheets. You can still go and check the calculations. It's very good. The calculations are more complicated than what we have done in the class. Okay, but the format is not the same, so you can still look at the calculations. Anyways, but if you look at the Willie's book and the pocket book, you will see the same thing. Okay, so this is taken from one of those books. Okay, so projection, right? Projection. You are on the projection. Okay, so projection means this thing. I need to calculate this thing. Okay, so how do I calculate this thing? We take the width of foundation, which is 450, minus 127. Okay, and you will have both sides. You divide by 2. Okay, so this 162 is 450 minus 127. Whatever you have is projection on both sides. So divide by 2 to get the projection on one side. Clear? Okay. So this is 162 on one side, and you add it on the other side as well. This will give you a total width of excavation. This will give you total width of excavation. Depth comes from here. Okay. So 254. And then after 254, 150. So this is the depth of excavation. Clear? This is easy, right? It's written. Okay, so the depth of excavation. Now this is for the road, and then for the path, we know the length is 10 meters. Okay. The depth, you come here, see this one, 50 meter this, and this is 150 meter. So 50 plus 150, 200. Clear? Okay. Then the width of the path. Okay, the width of the excavation, which we will take for the path. Okay. So 1 meter from here to here. Okay, 1 meter from here to here. Minus 289, which we already took from here. So 289, as you can see, is 127 plus 162. Okay, 1 meter was this one. Okay, so when I was doing the excavation for the road, I already counted this, right? Okay, I already counted it. So from the 1 meter, I will subtract this thing and subtract the projection as well. Okay, so subtract this and this. 289. Okay, and what is 51 and 50? Okay. 1 meter was up to here, from here to here. Okay, so this one I already excavated, right? So I will subtract it. But this one I need to excavate, right? Okay, so I will add these two things here. So 51 is for the curve, and 50 is the thickness, the end thickness. Got it? Okay, 51 for the curve, and the remaining projection. Okay, projection is 50. Clear? Clear? Okay, so this will give me the width. So minus this, which I already excavated, plus this from the other side. Okay, so the width of the path which I need to excavate for bulk excavation is this one. Okay, total was 1 meter minus what I already excavated plus the curve on the other side and the projection on the other side. The final is 812 millimeters. Clear? Okay. So this is the width, the depth I already mentioned. So this is the excavation. This is for the path, 10 meter length. 812 means 0.81. Okay. And 0.2 is 50 plus 150. Okay. For the road, 30 meter here, 10 meter there, total 40. The width I calculated there. Okay. Width of the road plus a curve plus a spread or the projection. Okay. So total width and the thickness comes from here. 127 plus 150. So this is the excavation. Yeah, and right now what they are saying, the total excavation is the total material you will throw right now. We'll make the adjustment later, like we did for backfilling. Okay, so right now excavation equals to disposal. Excavation equals to disposal until you make that adjustment. Okay, now this is the excavation for the curbs. This and this. Okay, now remember, on the path, the curb is on one side. On the road, the curb will be on both sides. Okay, so I believe I forgot something. Should be multiplied by 2 on the top. Yeah, should be multiplied by 2. For the road. Okay, so for the path, 10 meter length. Okay, this one I already mentioned, it was what did it? Yeah, but we want to change. Sorry for that. 1.8. Okay, so 1.8. Okay, 0.18 width, 10 meter length for the path, and now why 0.05? The depth. Why 0.05? Is this 0.05 only? Huh? Without the curve? Why without the curve? This is not 50 millimeters, right? I'm doing it for this, right? So I took the width of this thing. Okay, I took the length of this thing. So why I'm not taking the height of this thing? The answer is, huh? We already did. Up to this level we already did, right? So I'm just doing the extra 50 millimeters here. Got it? Clear? Okay? So the extra 50 millimeters only. Same will apply here. I already did the excavation up to this point, right? I already did the excavation up to this point. Okay? So 40 the length, 30 from here, 10 from there, 450 millimeter. The 450 millimeter is the thickness, okay, and the height, the extra height, which is this one only. Clear? So whatever you did for the bulk excavation, after that, how much excavation you need? Okay. Now we are calculating the quantity of hard core. You can see the hard core over here, right? Okay, you can see the hard core over here. Okay, so the thickness of the hard core is already given, 150 in both cases. Okay, length I already know. For path 10 millimeters, for road 10 plus 30. Okay, so thickness no problem, length no problem. The only thing is how much should I take as the width. Okay, so this is what they have calculated for the path there on the top. So 1 meter was from here to here. Okay, from this 1 meter, I will subtract 127 for the curve. Okay, and 79 I will subtract from here. Okay, why it was 79? Because this is 51. The curve is 51. This one we took 50 in the previous calculation. The extra projection we took 50. Okay, so 51 and 50. The total is 180, right? So from 180, if you subtract 51 and 50, how much left? 79. Okay. Clear? So 79 is this thing inside. So here the projection is not equal. Here it was equal, right? We did divide by 2. But for the path it's not equal. So the actual dimensions will be taken. Okay. So this side is 50 and this side is 79. So I subtracted 79. So the hard core is from here to here. From here till here was 1 meter. From this I subtracted the curve, and from there I subtracted the projection of the footing. Okay. So this is 79. 127 is a curve and this thing is 79. Okay. So you get the width of hard core for the path. Okay, for the path. Okay, what about this one? What about this one? What will I do? The width is how much? 3.6, right? The width of the road is 3.6. 3.6 is this thing. Width of the road means this thing, right? From here till the other curve. Okay. From this, this is my hard core. So I need to subtract the projection. I already calculated the projection, right? This is equal. Okay. So I did it. It was 162. This thing. Okay. So it's equal on both sides. So from 3.6, you will take one projection from here and another projection from the other side. Okay. So 3.28 equals 3.6, the actual, minus 2 times the projections. Which projection? This one. Okay, the one which is for the road curve. Got it? Okay. And you will get 3.28 then. Okay. So length into width. Okay. But the quantity is still in cubic meters because it is hard core. It's filling. So quantity is still in cubic meters. So when you will put it in the BOQ, you will multiply with the thickness you have. Okay. You can read the things here. The joints are included and everything. Okay. Then concrete bed. This one. So concrete bed is on the road, right? So the width and the length is the width and length of the road. Make sense? Okay. This is where you will drive the car. Okay. So the width is 3.6 meters on the top, and length is 30 there, 10 there, total 40. Okay. Then you have the reinforcement welded fabric. So they will put something on the concrete bed or maybe under the concrete bed. Okay, so it's the same size as the concrete itself. Okay, so they will put a steel mesh. Okay, maybe I believe under the concrete bed. So it's a steel mesh. Okay, which is the same size as the concrete itself. Okay. Why they are putting it there? We don't know. But we don't need to know, right? We are not designing. They are putting it. Let them put. Okay, not our money, not our problem. Okay. Then we have the what is this? Yeah, the joints. Okay, So we have the joints. Okay, so there are 3 joints in this case. Okay, and the joints are where the slab is ending. Okay, the joints are where the slab is ending. Okay, so we have one end here, other end on the top, and the third end on the side. Okay, so at the end where the slabs are ending, we'll put these joints. Okay, and they will design the joints. So if you don't design the joints, we'll maybe put some glue like material, so you will have a bond and you will have it safe. So there will be no water penetration or something. Got it? Okay. So these are the joints. You can see 3. So 3 ends basically. So you can see the 3 ends over there. Top, bottom, and the side. Okay. Then we have the curve. The curve is measured in linear units. Okay, the curve is measured in linear units. Okay, so we have these curves. Okay, for the horizontal road. Okay, now you can see on the horizontal road, it's not completely straight, right? It's not completely straight. There are 2 curves at the end. So for these 2 curves, the curve will also go along the curve, right? Okay. So this 28.2 is without the curves up till here. 28.2 up till here. Okay. How did I get 28.2? The total was 30, right? The total was 30. Okay. From 30, they subtracted 2 times radius. Okay. Sorry, not 2 times. Sorry. They are doing 2 times there. Right? No, radius. Radius is 1.8. Radius is 1.8. Clear? Clear? Now, for this last part, the curve, they have calculated the length separately. Okay, so instead of a straight 1.8, now along the curve it will be 2.8. It will be along the curve 2.8. Okay. Now how do we calculate this? For this we need the length of the curve. Okay. For length of the curve, I need the angle and I need the radius. Radius I have 1.8. Okay. Angle I believe is 90 degree. You can calculate for 90 degree. Okay, should be 90 degree. You can see the angle, right? One road, other road. So what's the angle? 90. Okay, so it's 1 quadrant basically. 1 quadrant of a circle. Okay, so you take the total, divide by 4, you should be getting the same answer. Okay, but this is the length of the quarter length of the circle. This 2.8 is a quarter length of the circle. Got it? Okay, and it's on both sides, right? Top and bottom. So that's why I multiply by. And this 10 meters is for this curve. Okay, clear? So 2 for this one. Okay, then the 2 curves, and then we have the one which is along this the path. Okay, what else we have? Now macadam means the surface. Okay, so they are putting the macadam on the path. Okay, they are putting the macadam over here. Okay, so the macadam will be from this side to this side. Okay, so these are the curves, right? I don't need the macadam here. Okay, so from here to here, it was 1 meter. Okay, from this 1 meter, I will subtract 127. So you get 0.82. Okay, and 10 meter is the length. Okay, clear? Clear? Okay, from here till the curve 1 meter. I subtract the curve, I get the width for the macadam. Okay, the surface, and they are calculating it as square meters, and you can see the thicknesses over there, and you can see the thicknesses are very small, 20 meters, 20 millimeter, 30 millimeter. The thickness is very small. This is what I said earlier. Okay. Then we have the deduction for the disposed soil, the soil which you will dispose. Deduction in that. We assumed earlier total excavation equals to total disposal. Okay, but now we are saying some of that we will use in backfilling. Okay, here the backfilling is quite easy, because where will you do the backfilling? On the outside only. Okay, you don't need to do any backfilling here, everything is filled. Okay, the only backfilling you need is on the outside. Okay, here and here. Okay, so 10, this is for the path. So 10 the length, 0.79 the thickness, the width, and 0.2 is the it should not be 0.79. 0.79 was the inside, right? 0.79 was the inside. 50 0.5, and this is 50, yeah, 50. 0.2 was excavation height for the path. Okay, so you will not do the backfilling over the, obviously the excavation you did, this is the same, you will do the backfilling. Where is it? Yeah. Okay, then we have 56.4, which is basically 2 times, because we are doing it on this side and the other side, right? We will do the backfilling for the projection here and the projection on the other side. Okay, so this is how I get 56.4. So you remember it was 30 meters. From 30 meters I subtracted the curved path, right? The curved path was radius 1.8. Okay, so the curved path I will take separately, which is 2.83. The length of the curve is 2.83. I will do it separately. Okay, but from the 30 meter I will subtract this path. Okay, so it was 30 plus 30, 60, right? Okay, 30 plus 30 is 60. From that I subtract the curve on the top and the curve at the bottom. So 1.8 from the top, 1.8 from the bottom. This is how I got 56.4. Clear? Okay. 30 filling here, 30 filling on the other side. Okay, and on both sides I have a curve. So I subtracted the curve from the top and curve from the bottom. Both sides 1.8, 1.8. I subtracted it and this is what I got, 56.4. Clear? Okay. So 56.4 is the length, 0.16 is this projection. Okay, we already calculated, and 0.4 is the height of the excavation you did earlier. Okay, the height of the bulk excavation taken as it is, no changes. Okay, and then we have for the curve is same as the road, right? Only the length will change. Okay, so this is quarter of a circle like I mentioned earlier. This is the projection, same, and then we have the height. Clear? Any questions? Okay, so like I said, we are only very few, so go home. If you stay here for 1 minute, anybody else will come and start again.